ACAN's 21st webinar. We'll be exploring building with natural materials. This week, we're back with our second instalment of our paints mini-series. Tonight, we've got 3 fantastic speakers lined up, followed by the Q&A session. And before we dive in, we'll start with a quick intro for those who may be new to ACAN, sharing who we are and what we do. ACAN is an open voluntary network of professionals from across the built environment industry. It was founded in 2019, born from a shared vision of working collectively and autonomously to address the climate emergency within the built environment. Our manifesto focuses on 3 key aims: decarbonise now, ecological regeneration, and cultural transformation. You can find more details about these on the ACAN website. And with that, I will hand over to Tom, who will introduce tonight's speakers. Thanks, Tom.
Hi there. Thanks very much, Steph. Yeah, so tonight, as Steph said, is a follow-up to last week's event on paint, which featured Caroline Nicolai, Michelle Brune, and Edward Bulmer, and it was a brilliant triplet of talks on paint. So you should definitely look that one up on our YouTube channel, along with the rest of the ACAN back catalogue. So tonight we're going to be discussing the role of paints and coatings on our buildings and the natural world. We're going to be discussing the environmental impact of the paint industry, but also how non-plastic mineral coatings can improve the performance of our buildings. So we will hear first from Paola Paruta, from the École Polytechnique de Lausanne, author of Earth Action's noted report, Plastic Paints the Environment. And following Paola, we'll have Tim Meek from University of Stirling, bricklayer turned academic and lime finishes expert. And finally, we will be joined by Anton Burkut from Keim Paints. So now I'm going to hand over to Aurore to introduce our first speaker.
Thank you, Tom. Hello, everyone. So yeah, I would like now to introduce our first speaker of the night. So first up, we'll have Paola Paruta. So after earning a master in mathematical engineering, Paola Paruta pursued a PhD in fusion energy to contribute to global betterment. And post-PhD, Paola delved into ocean plastic pollution, analyzing global plastic consumption and waste management on behalf of the UNEP and IUCN. In 2022, she led the research for the Environmental Action 2022 report, Plastic Paint and the Environment. Paola's research unveiled paint as a significant source of microplastic pollution on land and ocean, surpassing tyres and textiles, but she'll tell you more about that. And Paola is now exploring pathways to zero CO2 emissions in Switzerland as a scientific collaborator at the École Polytechnique de Lausanne. Over to you, Paola.
There we go. So today I'm going to present the main results of the report Plastic Paints the Environment, which is a report I've been working on I worked on in 2022, and it highlights the problem of microplastic pollution from paint. I tackle it from the point of view of basically as a physicist and a mathematician, so with little knowledge of the practice on the ground, which maybe sounds not so reassuring, but basically for me was quite frustrating to find out of such a big problem and have no way of contributing to its solution. And I hope that for you, because you work in the sector, this presentation might be empowering, because you might think that this is something that you can do something about. So let's start. Here you can see the front cover of the report and like a page taken randomly from the inside. So the report was published in 2022. It's Plastic Paints the Environment, its title, and it was published by EA Environmental Action. This is the company or research and consultancy that I was working on. And I worked on it with 2 colleagues, Margherita Puccino and Julien Boucher. So basically all of the content except 2 slides of the coming presentation will be from this report. So first of all, I don't know if you are aware of it, like maybe something that for you is well known. For me, definitely wasn't. The fact that plastic is a big component of paint, and on average, 37% of paint is made of plastic. And this is why, I guess, we have this much plastic leakage from paint. So leakage is just the term that we use in the community to describe, pollution basically from plastic to the environment. And as you know, paint is used in many sectors because it has protective properties. So it can be used in architecture, but also in the general industrial sector, in the marine sector. And this picture wants to kind of give a schematic overview of where paint is used and also what are the different pathways of paint and the plastic within it to the environment. So basically, paint can be lost during application. For example, one big one is overspray, but it can also be like rinsing the rollers or the paintbrush in the drain. It can be lost to the environment through wear and tear, so weathering or corrosion, so on and so forth. It can be lost during removal. This is, for example, you can think about for metal surfaces when you use blasting. You have paint going everywhere if you don't use a vacuum collector. And also unused paint, depending on how it's disposed, it can be mismanaged and end up in the environment. And finally, paint can be left on the object until its end of life, but then it depends what happens with the object and whether it will be well managed or not. Right. So what do field studies say about this problem? And I think one big thing was that until recently, field study didn't mention paint particles to be found when doing microplastic sampling and assessment. And I'm just gonna read through this extract from Turner paper in 2022. He says paint particles are denser, more brittle, more angular, less transparent, and chemically more heterogeneous than microplastic. And this characteristic may account for why paints are deliberately or operationally excluded from the overall microdebris pool in environmental samples. Nonetheless, recent studies do show that paint can make up from 20 to 80% of the microplastic pollution found in water all around the world. So you have this work from the UK in Europe, and then this other work in Korea and in Brazil. So we do kind of, this is to confirm that we tackle the problem from a theoretical approach, but we now have studies that do see paint as a main source of microplastic pollution. So what are the main conclusions of the report? The main conclusion is that there are 7.4 million tons a year of plastic leakage from paint to the environment. So of the 18 million tons, almost 90 million tons put on the market, you have that a big portion of it is well managed or embedded in new product, but then you also have that 4.7 million tons will leak to land and 2.7 million tons will leak to ocean and waterways. And of this, 1.9 will be in the form of microplastic. And this is maybe a bit tricky to understand why only a part is microplastic, but it mostly has to do with the fact that if a painted object is mismanaged and it ends up in the environment, that's not considered microplastic pollution. The same way that a plastic bag lost to the ocean is not microplastic pollution, but macroplastic pollution. But maybe it's a bit technical from the field, so yeah. And I tried to understand, to give a visual interpretation of how much is 7.4 million tons, and it's around 300,000 garbage trucks, or I thought, since you're architects, around the weight of 700 Eiffel Towers. So this is the yearly emission of plastic from paints to the environment. And architectural paint is the main contribution. This is not because architectural paint is particularly badly managed with respect to other sectors, but it's because it is the main sector that uses paint. So most of the paint is used in the architectural sector. Right, so if we do delve into the architectural paint, which I hope is something that you can relate to, the way the assessment was structured is to perform this kind of flow step-by-step assessment of, you know, paint being put on the market in the architectural sector and there's use cases. So it can be interior paint, and then we classify the exterior paint between concrete, so like, yeah, and wood. And then once so these are the type of paint or uses, and then paint can be lost during application by spray or by brush. You can have leftover paint. You can have paint lost through wear and tear, paint lost at removal, or that is left on the object until its end of life. And then each time you have a loss, then it can go through different pathways. It can be directly to the ocean, which is less the case for architectural paint, or it can first go to soil, which is the case, for example, for exterior losses of architectural paint or road. It can end up in wastewater, which is the case, for example, for washing the brush in the drain. Or it can end up recycling in these, I mean, the recycling of the painted object. For example, I don't know if you recycle the concrete of the building. And then finally, the fate of the paint can be that at the end of its lifetime, it can leak to ocean, to land. It can be well managed as waste, or it can be embedded in new product. If we look at this same schematic overview, but with the quantity, we have this Sankey diagram showing the material flow of the plastic within the paint and how it goes from use cases to losses, to pathways, and then to fate. And at the end, from architectural paint, we have 3.5 million tons of plastic pollution. So I don't know if it's clear here because the bars are different, but the bars are different, appears to be different sizes just because there are more categories and more white spaces sometimes. But so it's really like a mass conservation from one step to the next. And I thought, because I cannot show everything here, but this you can find it in the report if you're interested in looking at the details. I thought that maybe one easy one could be exterior wood. So for example, the paint is applied to a wood surface on the exterior, and then you have that part of it is lost during, for example, a small part of it, a very small part of it is lost during application by spray. And this is not because spray is a good way of applying paint, but it's mostly because we consider that the vast majority of the paint is applied by brush or roller. So, but overall, we have that the losses of spraying are 15%. So if you do apply something by spray, most likely is gonna 15% of it is gonna end up in the environment. And then you have losses during wear and tear, but then you can also have losses at removal. For example, when you do sanding, if you don't vacuum it directly or just after and you just let it fly in the environment, I mean, it's gonna go directly to soil or to road surfaces, and then from there it becomes a leakage to land. And a part of it you see here from soil, you have a small part that still goes as leakage to ocean and waterways, and same from road, because you can have road runoff. So for road is a much bigger portion that is transported to ocean and waterways. Yeah, interior paint is mostly used for interior. So sorry, I don't want to use too much of my time, but right. So for unused paint, we used a conservative approach of assuming that paint is disposed of as hazardous waste or general waste. And this might be a weakness of the assessment, in the sense that later we discussed with some people from the field that had the feeling that in practice, unused paint is likely to be mismanaged. But still, since we didn't have numbers or figures, we stick to the legislation that labels paint as hazardous waste in most countries. And then losses at application, since rollers and brushes are used, is 1.5% most of the time. Wear and tear, we have the 1.2 million tons of microplastic, wear and tear will lead to 1.2 million tons of microplastic to the environment from architectural paint. Removal of paint releases 800,000 tons, and exterior surfaces are often contributed directly to losses to the environment, while removal of interior paint is usually leading to is usually going to waste management. Renovation and demolition, 70% of residual paint is lost, releasing 1.2 thousand tons of microplastic. So here are the different losses mechanisms and how much we estimated they contribute to the total 3.5 million tons of plastic pollution. We then collaborated with other experts from other sources of microplastic pollution to work for the European Commission to basically, which is called EU Actions Against Microplastic, and the results were published in 2023. And as you can see here in this graph, depending on how, you have this uncertainty interval, but paint appears to be the leading source of microplastic pollution in Europe. And in the report, you can find this statement that is releases during application, wear and tear and removal of paints are estimated to represent the largest source of unintentional microplastic pollution. Of the 2.3 million tons of plastic polymer used in different types of paint across EU in 2019, approximately 21% will leak into the environment in the form of microplastic. And that's it. And I don't know, I'm run out of time, right?
I think you're just doing fine. You did well.
Okay.
Yeah,
so I just wanted to briefly say this story that is maybe uplifting, linked to this picture. So this is a picture that I took at my university. And as you can see, there is paint scraping off everywhere, and you can see it a bit here on the ground, and then just at the bottom of this ramp, you have a drain. And so this was really like the example of architectural paint being subject to wear and tear and ending up in the waterways, because this university is then right next to the lake. And I decided I'm gonna take action. So I contact the person in charge of the sustainability, and they put me in contact with the person in charge of the paint. I don't know exactly if it's in charge of the paint, but anyway, he was the person responsible for this project. And we had a conversation, and I explained the problem of plastic pollution in paint. And they decided they said they were anyway gonna repaint it, but they decided to, first of all, send someone every now and then to clean up, to make sure that the paint was not gonna leak in the meantime. And then they removed it using vacuuming. And finally, they're gonna use mineral paint to repaint. So this was my small success story from all of this work.
Thank you, Paola. Thank you. That was scary, but extremely interesting, and I'm sure a lot of us learned a lot there. So if you've got questions, please put them in the chat box. Let's see, got a lot going in there already. We'll read them out at the end when Tom will be chairing the Q&A. But next, we've got Tim Meek. So Tim is an apprentice-trained, award-winning bricklayer with a degree in archaeology from the University of Newcastle upon Tyne, and has a master's from York University. He retired from construction in 2018 to undertake a PhD at Stirling University. It's called Cultural and Physical Factors in the History and Development of Traditional External Wall Coatings in Scotland, published 2023. Tim is also co-author of Historic Scotland Technical Papers 31 and 33. Throughout his studies, he had continued to work practically as a builder to help develop a better understanding of Scotland's intangible building heritage and the immaterial values of the generation that preceded him. Major projects include the Great Hall of Stirling Castle and Kilco Castle. Over to you, Tim.
Now, I have all the imagination of a field bowl, so I'm only interested in the facts and how the data stacks up, and this is at the core of my talk to you today. I stand before you as an academic and tradesman, which, for all our lack of safety, undisciplined approach, our filth, our mess and drunkenness, cheers everybody by the way, we still managed to produce the mason architects of the past, men like Palladio and John Milne and William Adam, who understood the relationship between form and function, I guess in all its detail. So I want to ask you not to accept the conclusions of this talk, but to consider them relative to how people have identified themselves in the past and what this means in terms of the functionality of the building process. We've moved from masonry understood to be covered to architecture where the expression of the joint in parallel with bare stone has become everything. We've settled into curated neglect rather than a reflection of the aspirations of those who commissioned work and the intangible heritage of those who undertook it, us. I was asked to give you a talk about lime wash, but this is difficult because it's the final part of an integrated building process, and as such, I don't think it should be separated. So the aim of this talk is to demonstrate the physical and cultural importance of lime wash as part of a complete building system. Conservation has come to mean pointing, and within the canon of pointing, the process is one-dimensional, a single universal style throughout the country, what Dr. Gerard Lynch calls the heritage joint, which has exposed architecture to the loss of fabric rather than its care. So how have we got here? The age of enlightenment augurs a way of looking at the human experience rationally, with systematic multiple observations to make sense of the world. But systematic analysis is not a force adopted by 19th century architectural historians who were influenced by art, religion, politics, and the combined notional ideas of truth, honesty, and morality. And this is best appreciated in Ruskin's The Seven Lamps of Architecture. It's the opinion of a wealthy intellectual elite motivated by romanticism rather than an evidence-based analysis. And despite the many critiques of Ruskin and the attempt to place him within the context of his own time, and I have some sympathy with that, we can take him at his word, and we can do so because we remain tied to a flawed ideology that ascribes animistic values to buildings which they don't have. They're buildings, not sentient beings. In inverted commas, the true colours of architecture are those of natural stone, doesn't stand up to scrutiny. The true colours of architecture, whatever cultural, political, religious and environmental constraints there are at any given time, in inverted commas, but to cover brick with cement and to divide the cement with joints that it may look like stone is to tell a falsehood, ignores the presentational and functional values that overwhelms us. In inverted commas, all the fair devices that were ever fancied are not worth a lie. Leave your walls as plain board or build them of baked mud and chopped straw if need be. But do not rough cast them with a falsehood. This displays the most profound lack of understanding of the vernacular building process with no substantiating evidence. Ruskin's difficulty in reconciling his own religiosity with science was inherited by Morris and Webb, And that reluctance to consider evidence systematically and impartially remains at the heart of the heritage industry. And the practice of conserving ruins morphed into the conservation of roof buildings. So archaeology has become a finish rather than a process, and minimum intervention doesn't stop decay. The science on that is really clear. Water, temperature, salt, biological growth, pollution are the causes. And yet we're practicing curated neglect under the twin banners of honesty and archaeology. So there's a dissonance between the evidence and conservation strategies. The Ruskin view that stone is inviolate has inhibited the heritage industry from academic or practical inquiry, a position supported by the principles of conserve as found and honest repair, which have been adopted by the international charters. You couldn't make it up, really. The principles of conservation have become the problem. Recent research demonstrated we knew very little about lime coats in Scotland, so we adopted a no previous knowledge baseline. And the fieldwork identified a thread of completely covering buildings, primarily with Hull from the 12th to the late 17th century, when we see the introduction of bare stone. And that evolution takes place in several forms and made clear with a study of over 300 examples. The study began as a desk-based analysis in a number of locations. In this example, Edinburgh Castle, we used evidence from prints, which questions the current presentation. In the past, hard and lime-washed, now bare stone. Early 18th century paintings suggest a different narrative for the Edinburgh Old Town, a World Heritage Site. In the past, hard and lime-washed, now the Heritage Joint. A position substantiated by archive photographs. The collective desktop study was then compared with the on-site evidence, which within the context of the heavily clean Canongate, we found only fragments. Nonetheless, you can begin to build up a compelling story by integrating different evidence sources. Early Hull was thick and applied as a single coat. If we look at the timeline, we can see there is a gradual reduction in coat thickness, which is relative to the refinement and Renaissance architecture of the 16th and 17th century, levelling off in the 18th. The evidence tells us that as lime coats become thinner, there's also a reduction in wall width and a further reduction below the windowsill in a residential building of the long 18th century. Finally, we identified that the use of lime wash declines in the late 18th century. What you can see in the earlier examples is likely to be wear bias. In other words, it doesn't survive well. Lime wash appears to peak in the early 19th century and decline thereafter by a combination of factors, including no longer fashionable, removal, and wear. We cannot dismiss wear bias. So the data is at odds with the pictorial evidence from much of Europe, where plaster, colour wash, sgraffito, and fresco were commonplace. When we look at the evidence from paintings and cross-referenced it with archaeology, we found that polychromatic finishes survive well in parts of Europe where Catholicism has been retained. But what is also significant is the use of lime wash in strategic areas where the focus was at street level, and more specifically around doors and windows, again a position substantiated by archive images and the on-site archaeology. In this example, multiple coats of lime wash applied to the cut details, folding around the chamfered margins and into the window frames, leaving us with a sense of plaster and lime wash used to manage the external and internal environments, creating an atmosphere that was both seamless and seamly. You begin to get a better understanding of the cruciality of triangulated evidence, a methodology we've not previously been very good at. And there's a reason for this. An 18th century watercolour and archive images from 1913 of St Clement's Church, Rodal, show the church with almost complete lime cover. But we also found a rare documentary source with architect Alexander Ross proclaiming, "The writer of these notes had the pleasure of removing the plaster from the walls and repointing them." By the way, that's my 19th century voice. We've been removing finishes for nearly 200 years, and we've grown used to a bare stone aesthetic. As I highlighted earlier, in the late 17th century, lime coats thin. And ultimately, bare stone becomes the dominant expression of architecture. And thereafter, we see the arrival of what we now think of as pointing. We identified 16 different pointing styles in Scotland, and the overwhelming commonality was formality achieved by lining out. And there's been a consistent response to TP33 running along the lines of, well, I don't like any of these, Boy, do I want to be really clear here. I'm not asking any of you to admire the examples. I'm offering them as evidence. Should our preference be dictating policy? If so, what is it we're conserving, and crucially, for whom? The morality of using lime has exceeded the function. We seem to have abandoned our understanding of how different materials work in tandem. An understanding of how all the different elements of a building come together is crucial. So, by putting the elevations, sections, and plan together, we can understand wall morphology as a series of substantial piers, triangulated at the corners, and linked by insubstantial ties. Externally, there are stone lintels with timber supports behind them, onto which the masonry is placed. This houses the floor joists. It's a relationship that's dependent on everything being dry, which is unlikely because the area is prone to cracking. And this pattern of cracking from top to bottom was near universal in residential buildings throughout the long 18th century. Let's talk about climate. These are Met Office rainfall and wind distribution maps of the UK, and you can see just how wet and windy the north and west is, with gusting wind speeds during storms Aidan and Ciara of up to 70 miles an hour. I want to now look at proof of concept and applied science. Storm conditions with low air pressure are accompanied by wind and rain. The wind that flows around a building is described as dynamic pressure. This is a very general computer fluid dynamic illustration, the blue representing low pressure. And you can see that there's a difference in pressure between the front, rear, and sides of the building. But there's also a difference between the external pressure on the windward elevation and the interior. Let's give more clarity to that general picture. At the external wall face, the velocity of wind is curtailed abruptly, creating kinetic energy and high pressure. We know that all buildings are not airtight and there are cracks often tiny in all elevation. On the windward side, there is air-water infiltration. If the sum of exfiltrating air is less than the sum of infiltrating air is less than the sum of exfiltrating air on all the other elevations and the roof combined, then there will be an external, internal pressure difference. In conditions of wind-driven rain, water enters the building envelope via two agencies, capillarity and pressure difference. So, hypothesis. Pressure differences combined with structural deformation can be negated by complete lime coats. We built an airtight chamber and used a dust extractor to replicate the pressure variables expected in storm conditions. And the testing regime used was the ASTM standard, which measures air leakage in new buildings at 75 pascals. The baseline for this experiment is 70 pascals pressure difference, and the irrigation system delivered water equal to an exceptional but not unheard of event based on Met Office figures. We also looked at real pressure differences in storm conditions. These readings were recorded during storms Aidan and Ciara, from left to right, 280, 90, and 120 pascals, so we can feel absolutely secure that the testing regime is robust. Two binder types were used, NHL2 and high calcium. First, the NHL. Pressure difference makes a significant impact when a wall has no surface treatment and where there are very small cracks at pressure differences from 0 to 70 pascals. With no pressure difference, the rate of water entering the chamber via capillarity was 125 millilitres per minute. At 70 pascals, that increased to 375. You can see at the base of the graph are the various lime treatments, so let's expand them. We can see that all the treatments improve matters. The green indicates the heritage joint. This type of pointing is the least effective, while full rough cast and lime wash the most impactful. When we ratcheted up the pressure difference beyond the 70 pascal baseline, there was an exponential increase in inundation. In this case, we compared the difference between high calcium and hydraulic mortars. The most significant outcome here is the amount of water entering the chamber in the high calcium mortar scenario, and this can be accounted for by the amount of shrinkage within the mortar after 3 and 6 months. In contrast, once the high calcium hull had been lime washed, no water entered the chamber, hence there's no graph line. The difference between the effectiveness of the two mortar types is actually very small. The difference between coated and not coated colossal, and lime wash is a crucial component. Today, we'd call them conservation builders and heritage specialists, But this was seasonal work done by ordinary people all over the world for millennia to get the best out of their buildings and make them presentable. And let me be clear, mixing colour is an absolute doddle. There is no evidence to support this approach, and yet it's sanctioned at the highest possible levels. There is a shared silence in heritage made increasingly awkward by the evidence. Evidence which, once seen, cannot be unseen. Conservation has become a set of interconnecting homilies that has been repeated so many times they've solidified into an acceptable narrative of doctrinal instruction. But hey, let's finish by ditching the science, archaeology, and conservation philosophy, and instead ask ourselves a simple question. Which of these two services is likely to be resilient in a climate change future? And if you have been listening, well, ta very much, and do join us at the Lime Finishes group.
Thank you, Tim. That was amazing. So much information in there. I'm going to have to rewatch it all. I'm sure there are a lot of questions there. Please keep popping up them in the chat box, and we'll read them out at the end. It was fascinating. Okay, then we've got Anton, our last speaker for the night. So Anton Buchert, and from KIME. So Anton joined KIME in 2014 and is the National Architectural Business Development Manager. His role involves site visits to advise and offer guidance on projects, provide specifications, and complete color matching trials. Also working with architects on bespoke project specification and providing CPD presentations. Over to you, Anton.
Thank you, Aura. Thank you very much. Thank you, Tim and Paola. That was, wow, amazing. Some really fantastic presentations there. I just wanted to mention very quickly from Paola's presentation, I just made some very quick notes of things that some of the audience might be interested in looking up or just thinking about. Paola mentioned about overspray and a certain loss of paint from that process. From my experience, the spray machines used on particularly sort of commercial sites, they're designed to hold a minimum amount of paint, which could be, for example, 5 litres. And if you only need 1 litre to paint the area you're working on, then you've got 4 litres of waste paint straight away. So that's something to think about. Something I have discussed and sort of looked into previously on this sort of topic as well. A huge impact is done by decorators, and I still see this. I saw it last week or the week before. They're actually washing their brushes and rollers in particular, in the washing machine. So they'll probably try and scrape out or rinse off most of the paint that they can, but there's a lot of people who are just putting their stuff straight in the washing machine, and it's going straight into the water that way. And something more positive that has come out of that is if you want to look up a company called Washbox Global, they recently won a ASBP award. Andrew Crimpston, I think is the chap's name, but they work on a commercial and a smaller scale. They basically have these facilities that can go onto site, and the decorators can actually safely wash their decorating equipment without contaminating the water. But I'll leave that there because that's their technology and not my area of expertise. So without further ado, I shall continue. So yeah, looking at exterior silicate paint technology. This is really just to give you a bit of an overview and a bit of an education. There's our founder, Mr. A.W. KIME. KIME was invented back in 1878. Looking at the presentation overview, we'll go through a very brief history of mineral paints. Why do we paint exteriors? Sustainability, ingredients, durability and longevity, some comparisons with conventional acrylic masonry paints in particular, our different external paint systems, and some example projects and coating options. This isn't meant to be a sales pitch. It's really just me passing on my experience and the experience of KIME as a company with our natural paints. So in terms of history, roughly 65,000 years ago, mineral paints were first used in cave paintings. 1768, a gentleman called Johann Wolfgang von Goethe discovered a product called water glass, and I'll come back and discuss that a bit further because it is part of our paint systems. 1878, as I said, Mr. A.W. KIME actually used the water glass to create the very first KIME mineral paint called KIME Procrystallat, using liquid and powder components. It was very much a hands-on, make-it-yourself sort of paint system. You know, it didn't really come in a tin, but that product is actually still available to this day, and it hasn't changed in terms of formulation. 1895, the artist Anna Lee Merritt is the earliest recorded use of mineral paints in the UK at a church in Blackheath. 1962, Kyme introduced our second generation of paint system called Kyme Granitol, and this was trying to move to a more friendly for the decorator or applicator paint system, so it was ready in a bucket, so you didn't really have to sort of make it yourself. 1978, Kyme was formed in Telford up in the UK, just to the west of Birmingham, so we're sort of centrally Midlands based. And 2002, we introduced our third generation of paint called Kyme Solidlit, using a new binder called Sol Silicate or Silica Sol, which basically means that that particular paint system can be painted onto totally bare substrates, and it will chemically bond and introduce high breathability, but it does work on sound previous paint coatings as well. Looking at this next slide, why do we choose to paint exterior of properties? Main reason is to protect the substrate itself from weathering and erosion by the elements. So for example, wind, sun, rain and frost. In terms of cost, maintenance and time, it's always better to protect the substrate than have the substrates, from our experience, sort of eroding and degrading and then running into possible repairs. You know, we're talking about renders, traditional renders, etc. Visual impact and design, that could just be another introduction of, you know, wanting to introduce a personal touch to a project, introducing color. These photos are from a project called Mangalam 21 in Albania, with a variety of different Kyme finishes. It's actually a huge sort of residential site, lots of lovely color introduced, and it's all using natural materials. So it's quite an interesting project to look up. So why use Kyme mineral paints and why not conventional exterior masonry paints? Or you could say, you know, why use natural paints as well? I'll be quite blunt. Do you want to cover your building in plastic or not? So looking at this comparison between Kyme paints, mineral-based and acrylic-based paint, it's not an exhaustive list. In the green, we have Kyme paints, and there's three parts to the paint system: a carrier, a binder, and a color pigment. For Kyme, we're using water as the carrier. The binder is potassium silicate or water glass. The color, we only use natural earth oxide color pigments, which are mineral-based. With conventional paint systems, acrylic-based, the carriers can be solvents and or water. Binder, you're looking at alkyd emulsion, polymers, oil-based binders, latex binders, vinyl or PVA, styrene, 100% acrylic, or basically plastic to a degree. Colors can be acrylic colorants, some natural, but mostly sort of man-made. So the sustainable certifications, compatibility, and other bits I should mention. Obviously, we have various ISO 14001. We're active members of the Alliance for Sustainable Building Products, and we're also actively involved with the Paints and Finishes group. BREEAM and WELL, that relates more to internals, but we can meet those requirements as well. We have Nature Plus certification using 100% green electricity as an example, and Cradle to Cradle silver certification, and we also have Material Health Gold. So they're just some independent verifications. Looking in more detail at the ingredients, again, just to give you a feel, the first part that we use is something called water glass. We don't actually make this. This is something already available on the market, and I can give you a couple of examples of what it's used for, or three actually. It's used to coat the ends of electrodes on welding rods to stop the electrode getting damp. So when a welder comes to strike his spark, the electricity can pass through and it's not being blocked by moisture. It's also used in makeup packaging, and it is actually used partly in makeup as well, I believe. But back in the war, it was also used as a liquid to coat eggs. And people would actually store them in their outhouses, in their back gardens, and coating the pores of the egg would actually keep it fresh for up to a year. I think they're quite brave. I don't think I'd like to try a year-old egg, but apparently it did work. And we attend things like the listed property show in London, and actually had a customer, you know, explaining this to us. It was quite fascinating, actually. But to make the water glass, or for the water glass to be made, the main ingredients: quartz sand, potash and water. That's heated to 1400 degrees C. The CO2 leaves the mixture, and we're actually left with this green crystalline glass rock. It's basically glass. You can't use that as a paint, so it goes through another stage. So that crystalline rock and water, bit of secret technology, heated under pressure. And then, I don't know if you can see my mouse, but we basically have turned that crystalline rock into a liquid. That is then mixed with rock flour and natural earth oxide color pigments, and that actually makes the Kyme mineral paint. And these are all made to order because they're natural materials. We don't have warehouses full of paints, purely because it sort of starts to settle and cure itself. So it's all fresh. I hope my screen's keeping up. It was just warning me of low system resources, whatever that is. Durability and longevity. So a conventional film forming coating just sits on the surface. So you basically have the application of the paint. So this is looking sort of from top down on a wall in the wrong direction, unfortunately. But the paint is applied onto the surface, and you're having a, so I've just got something in the way, a solid liquid interface. Then the film formation is actually happening or occurring. So you have evaporation, particularly of VOCs, volatile organic compounds and solvents, cross-linking of the polymers within the paint itself, and shrinkage. And then as the film is curing, it's basically shrinking and sticking onto the surface by mechanical adhesion. So it's not penetrating into the substrate, it's literally just stuck on the surface of whatever you're painting. Conventional film forming coating common failures that we usually see in our role, peeling, flaking and blistering. And these are all mostly caused by excess moisture, either trying to escape from the building or the paint just cannot cope for the purpose it was being applied onto. It's just not suitable for certain materials. You know, you certainly wouldn't put a conventional paint onto a lime render as an example. It just will not work. With kind mineral paint or a mineral paint, the process is called sicilification. So the liquid water glass, we've actually tinted it green with the binder here, and it's penetrating about 0.5 micron. This is actually a cross-section of some lime cement render. The darker circles are actually the pores of the lime render itself, and even on a more microscopic scale, our coatings will actually coat the pores and not fill them with liquid. So we maintain breathability levels very similar to traditional lime render. So it is highly, highly breathable. That paint coating has actually become part of that mineral substrate. If you're looking at something really dense, like concrete or stone, if you wanted to paint those items, you can. We have actually applied our coatings onto granite. You won't get that depth of penetration, but we can make our paints chemically bond to granite, so they won't just peel off or flake off. So it can be an extremely durable and long-lasting paint system. So some comparisons between KIME and conventional exterior masonry paints. So this is a little bit of a list, really. Highly breathable, SD values of less than 0.1 meters. So we're amongst the lowest moisture resistance on the market. Conventional exterior paints can have or do have very limited or even no breathability in some cases. Totally color stable mineral paints. Sorry, I've just got to move something. The colors are guaranteed not to fade because we're only using natural earth oxide color pigments, and it's a waterborne product. Conventional exterior paints are not color stable colors, and they can and do fade. And I've seen many examples of this through colored render even. You know, they're man-made pigments, man-made colors. They can fade quite terribly. Mineral paints resistant to mold, fungal and algal growth with a natural pH of around 12. Conventional paints, if the surface of a conventional paint does break down or break open or crack, moisture gets in, algal and fungal spores can enter, and they can actually feed and grow on the actual paint behind those cracks and surfaces. So they'll feed on the moisture, but they will actually start to eat the ingredients of conventional paints as well. Due to natural ingredients, UV light does not affect or break down the paint on a mineral paint. With a conventional paint, it can become embrittled and crack and fail due to ultraviolet in particular. Mineral paints are designed to work in harmony with natural mineral materials, and really conventional paint systems don't have a place to be used with natural materials. You shouldn't be using them. So I've just got to move this box again. Naturally light reflective due to crystalline construction, and a conventional paint has lower light reflectance, colors in particular. And just a few more as comparisons. So mineral paints, no microplastic contamination from erosion or wash off, and no wash off from cleaning brushes and rollers, etc. So with our paints, we do suggest to people, if you have any waste material, you should leave it to go hard. You can mix it in with sand. That can go either into the soil or vegetable patch. I do it myself. That's how I get rid of my small samples that I use in my job, or it goes into natural waste. Conventional paints potentially are a large contributor to microplastic contamination, as Paola's demonstrated earlier. Mineral paints inherently incombustible. Conventional paints do have plastic in, and plastic in paint will burn. You can set fire to conventional paints. Mineral paints, solvent-free, non-toxic, low VOC, Conventional paints, potentially high levels of VOCs and harmful ingredients which can be released as the paint cures, particularly indoors. Mineral paints, very high levels of durability. We have Stan and Rhine Town Hall in Switzerland, which is over 140 years old. It's never ever been decorated again. Commonly in the UK, we're looking at 10 to 15 years with a mineral paint system, and usually someone else will move into the property or the owners will decide to have a change of colour or redecorate anyway. With conventional paints, you're looking at an average lifespan of between 5 to 10 years with a good quality conventional paint. So just to give you a few names of our exterior paint systems: Chyme Solidlit, ideal for new and unpainted substrates and sound existing paint coatings. Chyme Granitol, which is fantastic for new unpainted surfaces. Concretal Azure, which is a colour wash for visual concrete. Restore Azure, this is a colour wash that we can use on brickwork and stone, either for matching in repairs or for complete changes. Chyme Concretal Black is specific black paint shades, essentially. And our Chyme Twin Star is some new technology. This is actually a one coat, or we say one coat, it's a wet in wet 2-coat silicate mineral paint system. So potentially if you've got access and the right team, you can paint a whole facade in one day. And this is just the example of City Hall in Schweiz in Switzerland, originally decorated in 1891. And these buildings still look absolutely fantastic. And our colleagues around the world have always said, there might have been the odd repair here and there, but generally these have never, ever been repainted. They just don't need it. The paint or the material that was put on just works and lasts, and the colours don't fade. Probably the air quality helps as well, I'd imagine. Some example projects, just to give you a bit of a feel, hopefully. So concrete, visual concrete externally. So this is the famous Park Hill Estate in Sheffield, Hawkins Brown Architects and Urban Splash. The exterior framework, you can see the smaller picture to the right, that was the sort of before essentially, and on the left is the after. So all of the glazing, the panelling has been replaced and updated. The concrete frame was sort of cleaned. There were some areas of spalling and broken and damaged concrete which needed repairs, so those repairs were carried out, but the actual repairs could be seen a little bit too vividly for the architect's liking and the client, and they approached us and we all worked together, and we created a colour wash. So it's not a solid thick paint. This is a very sort of subtle wash that goes onto the concrete to actually blend in those repairs, and it does a very effective job. I've spoken to lots of sort of junior architects and beginner architects, and they've been here and had no idea there was anything on there in terms of a coating. Sorry. Concretal Black, this is a series of black concrete shades. In isolation, these colours do just look black, but in this picture, you'll see there's very subtle shades of green, blue, red, yellow, and green, I think, just fired into the mix. So as soon as you put it together, you can see those different sort of shades of black. So it's just something a little bit different. Brickwork, this is a wonderful project called 27 to 29 Whitfield Street near Goodge Street Underground in London. And this was with Stagg Architects and Ben Stagg. I love this one. It's one of my favourites. A fantastic retrofit example. So in his building on the left-hand picture, you can see the before there. All of those rendered panels were actually a sort of concrete render. That was fully removed. We helped with some samples of our Restore Azure colour wash for the brickwork. So we're not painting it in a thick paint. This is just a colour wash again. And you can see the image on the right-hand side afterwards. So it's all about retaining that existing structure, not putting more carbon into the project, but having a very, very low impact into it. But it's totally transformed it into an almost brand new looking building. And if you get the chance to see it in person, do have a look. Something quite different we can do with our mineral paints here for brickwork is actually a colour wash for brickwork. So this is a project, Union Court in Clapham. So you can see the picture on there before on the left-hand side. We tested some samples on site with the architect and the client, as you can see in those other photos. There was even the question, do we paint in the mortar joints or not, or leave them as they are? And I preferred them left as they were. And that's actually the transformed building afterwards. The intention of this really just to freshen up, brighten up the building and make it more attractive to new tenants. And I think it did the job. And honestly, standing across the road, you wouldn't have an idea, just looking at this building, that it's been painted at all. But again, it's not a paint, it's a stain. So when you look at this in person, you can't really tell there's a paint coating on there. Nearly at the end. Hackney Peace Mural, Carnival Mural by the muralist Ray Walker back in 1985, restored in 2014. So this is using our Chyme exterior paint, Chyme Solidlit, lots of different colours. just to create this fantastic mural that's on the wall there. Breathable, durable, natural earth oxide color pigments, fade free, and certainly no washing off of microplastics. Example of the twin star paint system. So this is the 2-in-1 or the wet and wet exterior masonry paint system, just applied onto a rendered property, lime rendered property in Cornwall, against the natural stone walls there. So just a idea of this one is really time saving, labor saving, cost saving, and you're using less materials and less cleaning and washing of the tools. So potentially on a larger scale, you're not having all of the sort of wash off of all the waste paint. George Hotel, High Street, Rye in East Sussex, Grade 2 listed, using our kind of solderlet paint system and some repairs to a brick facade. Again, just a lovely sort of natural looking protected surface. Metallics, I won't go on too long about that. So yeah, we have a range of mineral metallics as well, so you can really get quite adventurous. And you can see the color swatch just on the bottom right there. Huge, huge, huge range of colors. So you can create feature walls, even externally, it does work. Very popular in Paris. Two-part system, so you can adjust the opacity and a great range. Renders we do, I'm almost out of time, so I'll just show you that one. We do have a showroom if you're based in London, or if you're visiting London, at the Business Design Centre in Angel Islington, open every Wednesday or by appointment. Lots of different systems. We even have a titanium dioxide free paint. That's something quite new that we introduced last year. Various textured grob base coats, lots and lots of different treatment systems as well, but we try to keep everything in that sort of ethos of being sustainable and healthy. Color swatches, samples available, and we're on various social media platforms, so you can either have a look and see, there's usually lots of news on there or example projects and what we're up to, so quite an interesting way of keeping up with this. So I shall stop waffling there because I think I have run out of time. Yeah,
that's fantastic though. Thank you, Anton.
You're welcome. Thank you.
Really appreciate that. Yeah, worth saying that mineral silicate paints are available from not just Kime, but other.
Correct, yeah.
But yes, but thanks so much for sharing that with us, all of you. I mean, that was such a brilliant and wide-ranging conversation. But I personally really enjoyed the kind of the breadth there and the interrelation. So yeah, Paola, we've got a bunch of questions for you all here, but let's just get them up in front of me. Yeah, so your everything you were discussing there couldn't have felt more pertinent right now. I've been reading a lot about the sort of impact of plastic pollution, ocean plastic pollution on phytoplankton, and the capacity for plankton in the ocean to absorb carbon dioxide. So it's it's part of this all part of this pretty grim picture that we're living in right now. But Tim actually asked, given that previously architectural paint was largely lead based, I wonder if it's simply the case that until now paint has always been damaging. I don't know if you have any thoughts on that, or whether.
No, maybe, I mean, I don't know much about the history of paint. I know like lead paint was used, but I know like silicate paint was also used before plastic based paint. But I think maybe like my presentation focused a lot on the negative side of paint, but obviously paint protects the object from, the elements, and especially exterior paint. So it has a functional purpose that lengthens the lifetime of the object and reduces environmental impact in that sense. So I mean, definitely lead paint for water pipes, as the Roman did, was not great for health. But I'm saying like that the solution is not don't have paint, because then things would rotten, and then you would have to incur much more waste of the painted object, basically.
Yeah.
And maybe I just wanted to say, in terms of the importance of microplastic pollution, especially like why we focus a lot on that, like, because the main source of plastic pollution is still macroplastic, especially in developing countries where waste management waste is poorly managed. But and then eventually macroplastic breaks down in microplastic in the environment. But the main concern, like health concern for humans, is the fact that once it's in the water, it can end up easily in the food chain, and so you find microplastic in fish all up to the chain of the fish that we eat, and it's not clear yet how it impacts us as human, like the interaction that it has on the health system.
Yeah, yeah. I mean, has the report, I mean, it must have had a lot of what have been the kind of responses to the report from kind of either end of the spectrum? I certainly know that the paint industry has had a lot to say about it, but I wonder if it's had any more positive traction as well.
From the paint industry?
But perhaps from regulators, from interested bodies, architect bodies, or anyone really. I mean,
definitely the people that contact me directly are mostly to say positive things and to be thankful. But indeed, like the SEPE, this coating, I don't know if everyone knows SEPE, but when we did the work for the European Commission, they were the biggest lobbyist group that we interacted with, kind of, underlying the importance of coating and paint, of course. And sorry, I was lost in thought a bit over there. But I think, from the point of view of the regulators, so the really like the European Commission, the people from the General Directorate for the Environment, I think they're called, their frustration with paint was that ideally they wanted to propose solutions for the problem, like basically present the problem and present solutions at the same time of how to solve it. But because the issue was not so well studied, and I think also my feeling is that a lot of people that work with paint daily, they're not aware that paint is plastic. And I mean, I was not aware that paint was plastic. So just to say that I think a lot can be done in that direction of finding solution, and that from the point of view of the regulators, they're really looking forward to, for example, we suggested silicate paint or mineral-based paint, but they wanted to know, have we performed a life cycle assessment to know, is it worse at production, for example, manufacturing, is it worse than the impact that manufacturing of plastic-based paint can have? And these were all questions that we couldn't answer thoroughly. And then, I think a lot of the time, for example, if you propose also vacuum cleaning of surfaces, then the problem is that it takes a lot of energy, right? Like to run a vacuum blaster on the surface. So I think there are a lot of solutions to explore. And sorry, I was a bit long there.
Fine, it's all really interesting stuff. I mean, so Anton, I wonder if you've had any engagement with regulatory people, with people sort of trying to move away from plastic paint.
Not directly myself, no. I mean, what we do as being a member with brain's gone blank, ASBP, Association of Building Products. We try and educate people, whether they're homeowners, individuals, larger bodies, specifiers, architects, etc. Because it's still very much an educational process. There's so many people out there who don't understand what's involved, what the ingredients are, how these systems work. And unless you've really got time to look into it, it's quite difficult to learn and understand it. And probably, as you guys know, there's a lot of greenwashing that goes on. You know, people will tell you this, that, and everything else about their paint and how wonderful it is, and they plant some trees and everything's okay. And sometimes that's not the case. You do have to be quite careful.
Yeah.
Sorry, to say on this that, like, I feel also the focus was for a long time on like labeling eco paint. Like you can have plastic-based paint that is labeled eco paint by WWF, for example, because the focus was a lot on the solvent and the fact that water-based was better than VOC, I think, was it solvents that were dangerous for the people applying the paint when it was curing. So I think that also doesn't help, because there's been a work in that direction, and then the paints that are water-based are now labeled as eco-friendly, even if they have plastic. So it's quite tricky.
Yeah, they
Yeah.
still contain volatile organic compounds. And as you said, even for decorators who've been painting since they were children, or virtually children, or young adults, if they've been doing it all their life, it does have an impact on their health. It really does. I've spoken to a number of decorators who've noticed.
And on that one, check out last week's event, which will be on the YouTube channel. There's a lot of conversation on that topic there. Just quickly, one more for you, Anton. So Clement is asking, how long do your paints take to biodegrade?
It depends on many factors. If you had a very simple analogy is if you took a building in central London and then one by the coast, the one by the coast potentially is going to degrade more quickly from erosion due to wind and sand, etc. The paint isn't really going to degrade that quickly. This could take decades and decades. We've seen the example of the 140-year-old project in Switzerland. It can and does last that long. It's just here in the UK, we decorate buildings differently, and we don't necessarily maintain them. In that part of the world and in Europe, they've been taught and educated to wash their whole building. So the PVC, the windows, the woodwork, all of the painted masonry as well. We don't do that in the UK. But if you did, it could make a difference. But then, potentially some contamination of other paint systems.
But mineral paint or like silicate paint is not dangerous for the environment, right?
No.
Yeah. So I mean, even if it ends up in the environment and it doesn't biodegrade as like a biodegradable plastic bag, it's not.
It's essentially, in a very simple way, it's coloured rock.
Yeah, exactly.
That's what it is.
Yeah.
And it's all natural ingredients.
That answer leads quite nicely on to Tim, and the conversation there about maintenance, and also, I mean, so one of the questions that came in, should we be coating our buildings differently on different facades based on the orientation? I mean, that sort of relates to what we were saying there, Anton. So Tim.
Well, the short answer to that is yes, and I'd go even further. So taking my academics hat on and putting my contractor's hat on, I would adjust my specific mixes for specific areas on a building. So that area directly underneath the window sill, or between the sill at first floor level and the lintel at ground floor level, and further up, I would absolutely adjust my mix there, because so often the width of the masonry there can be 150 millimeters or less, which isn't covered by I don't have the BS standard, but it's the BS standard on what you can and can't leave uncovered. So if you were treating that building within the British standard, you would have to cover it anyway, but you would have to cover it with a robust mortar to take into account the amount of water being discharged from the glass rather than being discharged down the masonry. And that also applies to things like I don't know what you call them in England, the skew, the top of the gable, where the gable meets any coping stone, and indeed around chimney stacks, because chimney stacks, the masonry is very thin, and also you have the stack effect of air being drawn through the flue and reducing the pressure within the flue. So yes, I'm very mindful of that. I guess the thing that struck me about Anton's talk was the way that buildings shift. So I accept entirely that the material, the paint that you're applying is incredibly robust, and that it's a natural material. But what I wonder is what happens to that micro cracking, which would ordinarily be dealt with by continuous coating of lime wash. Do you see what I mean? And that filling process.
We would basically class that as ongoing maintenance in a way, and looking after the building, identifying issues as and when they occur. So if a building or a substrate is moving and you are getting substantial cracks or small cracks that are leading into substantial cracks, then those are areas that need to be fixed before they get worse. So you're not letting water into the structure or the fabric of the building. But again, our paints are actually breathable. They're genuinely breathable. So they will allow moisture vapor to escape. So I think you have a little bit of time before things get worse. You know, if you have a buildup of liquid water, then that's when things get a bit more serious. But from our point of view, it would be sort of maintenance of that facade in particular.
Yeah, so let's talk maintenance for a couple of moments.
Yeah, sure.
Because this absolutely cracks me up in Britain. I've just come back from Germany, giving a talk there, and I was so struck that in every single town, the buildings are clean, the rainwater goods are working, there's no buddleia growing out of the tops. I arrived back in Edinburgh, into the new town. It's a World Heritage Site, and every single building has got a defect up top. The rainwater goods are blocked. The joints are open. You've got plant growth in there. You know, we have to address this. I mean, what is the point in retrofit? And it doesn't matter whether we're talking about Anton's paint or whether we're talking about plaster and lime wash, unless we deal with the fundamental of keeping buildings clean and serviceable. What is the point in retrofit? I actually think it's time to start talking about the Danish model, where certainly 20 years ago, it was undertaken by the state and you were charged for it through your rates. So all the high level maintenance was simply done by a cherry picker moving down the street. And we just can't go on like this. It's preposterous.
No. Well, you see examples in the press, you know, the odd story here and there, or just walking down some streets, you know, 3, 4, 5-story tall buildings, and you can see the masonry literally falling apart.
Mm-hmm.
Who's going to be the poor person walking underneath that when it does fall down? Because it will, and it does happen. And again, that's the far end of how bad it can get, just through lack of maintenance and lack of inspections and just caring about the building.
Yeah. Yeah, I mean, I looked at a set of buildings I built about 15 years ago in Inverness last week, and it looks like the whole roofscape should be condemned after 15 years. I mean, it is that bad. It really is.
Right, isn't it?
Yeah.
And I mean, just pushing on that one is, you know, are you getting any, do you find any traction to this argument that I've heard you make, you know, several times before, and lots of other people? Is there a greater sort of awareness amongst, you know, elements of the sort of the broader industry with regard to maintenance? Or
see it? I genuinely don't see it. The number of projects where, as a contractor, we complete the works and there is nothing in the schedule for going back and re-lime washing 5 years after. There's nothing in the schedule for keeping the rainwater goods clear the following autumn. There is absolutely nothing. And that some of that is related to the way the grants are dished out. But some of it is people just don't think about it. You clean off your tools, take the scaffold down, and you know that's it done. It's great for the photographs from your Twitter feed and your LinkedIn posts, and
yeah, it's a real afterthought.
In the early winter, you know, we're back to square one with that, and it's so damaging, not only to the building but to the reputation of the materials that we're talking about today. You know, it's talked about lime failure. The contrary element to that, if I might for a moment put the other case for that. The British are absolutely remarkable, because we'll go to Florence and Venice and San Gimignano and we'll see fading, decayed renders over there, and then we'll come back to this country and say, oh, that's a horrible failure out there. But you know, I mean, it doesn't stack up. We have this sort of very mixed feeling about decay in this country. We sort of almost like it.
Yeah. Fascinating.
Patina and a feature of the building.
Yeah.
Until it gets very serious.
Yeah.
Yeah, no, it's definitely I know an area where I think we all need to keep banging that drum loud and hard. Right, so I'm going to push on with this list of questions I've got here. So yeah, Lucy, this one for you again, Paola. What does it mean in real life when paint disposal is, inverted commas, well managed? How can it be sustainably disposed of?
Yeah. So I think one example of well managed would be if for example, you have wear and tear of paint inside the house, and you vacuum it because it's dust, and it ends up in the bin, trash bin, and the trash bin is incinerated or put in an inert landfill, that would be considered well managed. If it's the demolished building and part of the painted material ends up in an inert landfill, that would also be considered well managed. And if it's embedded in new products, then it's also considered well managed, although like it starts a new life cycle and it could be lost at the next life cycle. But yeah, concrete, we know, for example, that it's used as like, it can be used as substrate for roads. Like it can be made into granulate and be used as substrate for roads. So it would be considered not in the leaked part, although I don't really know, like at that point, what happens to the paint that is still. So, and yeah, I think that's a bit the problem. The problem is that when you think of paint, it's hard to think what is the the well managed, you know, then it means that there is a problem, because concretely we think of paint as something that, I don't know.
Yeah, I've struggled with thinking about this before in the
yeah.
past. Think, okay, what is the end of life of a paint applied to a surface?
Mhm.
And I think in my head now it's either, yeah, potentially it can be because ours chemically bonds with concrete, brick, stone, whatever. It becomes part of that. So does that all get
Mhm.
crushed, used as road fill? Possibly
Mhm.
yes. Otherwise the paint's just going to erode, fail, break down, and just erode into the soil and the waterways. I
Mhm.
can't really. It's not like you can take a brick and remove the paint from it and reuse it. That's just not possible.
And
Yeah.
and even like when we were doing this assessment, the well-managed way of handling rollers that have leftover paint would have been trashing the entire paint roller, which is wasteful, but I don't really know of any other option that allows you to get it clean without paint going into the water stream.
Washbox Global. That company.
To me, it throws out. I mean, it sounds like we're kind of skirting around the obvious here. It's like we can't continue to use a fundamentally toxic, and I mean that in a big way, toxic to ecosystems across the planet product without thinking about it. There is no, to me, I would say there is no well-managed way of removing something that you've already taken. You know, you've performed entropy on these hydrocarbons. You've taken them from you know, a big scale to dust. And once you have dust, you can't reform that dust. You can't contain that dust. That dust is, you know, it's in the earth, it's in the water, it's in the oceans. And anyone who argues otherwise, I mean, we can all see the impacts of it, as much as the coatings federations might deny it. And it's a hard truth, but I think, like all of these things, we need to wrap our heads around them very quickly. That's my personal opinion. Right, but I'm going to ask another question to someone. Michelle Brune of Linseed Paint is asking you, Anton. Is the main difference between lime and chyme, or other silicate paints, the surface that it's applied onto?
I mean, as an example, a lime render, you can coat that in lime wash. You can also coat it in chyme paints. Personally, I think lime wash is a fantastic product, and it's definitely got its place. If it's done correctly, the person who's applying it or mixing it knows what they're doing. It can last a very long time. It can be durable. I remember 5 or 6 years ago, I was asked to a project in Norfolk or Suffolk, traditional cottage, lime washed. The owner actually said, "Oh, we're thinking about you know, redecorating. We think that this lime wash has had enough." I went to see it. It was 7 years old. There was nothing wrong with it. I said, "Give it a wash. You'll be fine for at least another year, 2, maybe more." So if it's the correct product, you don't really need to change it, to be honest. And that does happen occasionally. But I see far too many of sort of projects that have been worked on by people who didn't know what they were doing, and it can fail very quickly, unfortunately. But again, it's probably more of a skill or an education, or I'm not a lime wash expert, so.
Yeah. And I mean that relates to again Tim's previous point and question here from Anna and Amelia, kind of compound question. So it appears that many of us have forgotten how to care for, as well as paint and decorate our buildings, both inside and out. So why do you think this is, and what do you think is the biggest challenge for the conservation industry going forward? So I guess that's aimed at you, Tim, but actually questions there for all of you. So biggest challenge for the conservation industry going forward.
I think we have to wean ourselves off bare materials, bare stone in particular. We can't go on letting buildings leak and watching stone decay happen. We in some respects, we don't need another academic paper on particularly sandstone decay. We know why sandstone decays. It's relatively straightforward, as I made that point during my talk. The issue of water penetration is more complex because certainly pressure difference is a massive contributing factor. But the difficulty that we have is that we as a nation, we often argue that the wall is thick enough to be able to accommodate all the things that we want from that wall and leave it exposed. But not all walls are equal. A wall is generally made up of three parts. You've got an inner and outer leaf and a core, and those can separate out. So in other words, you've got an air-water gap in between those leaves. And there really isn't another solution to resolving that other than covering up the masonry. And we simply have to get out of the habit of thinking that stone has some sort of magical property about it. It's just a building material. That is all it is. The only thing that separates it from straw or from clay is the time of decay. It takes depending on the stone, if it's granite, it takes a hell of a long time to decay. If it's a robust sandstone, a little bit less than that. A softer sandstone, it can decay in 120 years. But we have to wean ourselves off that bare stone paradigm. And the other part of that is, as we've already said, maintenance.
Yeah.
Can I ask about this more for my personal, because when I was doing this work on paint, I thought about these red brick buildings, right, that are not painted. And I thought, that's a nice solution because you just don't paint it and it lasts. So it's basically what you're saying. Like in my imagination was like, you have stone or you have bricks and they don't need coating because they are resistant enough. But you're saying, I mean, because if it decays in 120 years, that's pretty much the lifetime of a building and it will be renovated or something within that time frame. But is it the problem that you have infiltration of water or humidity, and then it kind of breaks down the whole system of insulation or structural property much sooner than 120 years?
Okay, so we have to, for a moment, we need to separate out water penetration and decay, because water penetration can be as a result of decay, but generally water penetration is a product of microscopic structural movement causing tiny little air gaps. And so if you've got air gaps, you've got the possibility of water penetration through those air gaps. But just to go back to your point about brickwork, it really depends on when the bricks are made. So if they're Victorian engineering bricks, I accept entirely that we're supposed to see those. If we're talking about most 20th century brickwork, I accept entirely that we are supposed to see those as the finished object. If we're talking about Tudor brickwork or 17th century brickwork, that's a different matter. And the person to really speak to about that is Gerard Lynch. But in summary, what Gerard would argue is that those bricks are irregular in size, and therefore it's very difficult to keep the bonding characteristics really precise. And when you're dealing with elites and people who are ambitious, they're wanting to represent themselves as moving up in society, not as rural clods. So in the past, that brickwork was built, flush pointed, lined out, given a red wash, and then the lining out was picked out in white. So it has the appearance of brickiness, but it's not necessarily the finished object. It is the finish on top of the brick that gives it that appearance. And then if you take that a stage further, if you go to somewhere like Turin, many of the buildings in Turin are 17th century brick buildings in Turin. That brickwork is designed to take plaster, but more frequently, all the brickwork is exposed, and it's just a former for plaster. We're introducing our own British ethics into world conservation, which I find very disturbing.
Thank you.
Good stuff. Right, so Clement has been he's itching to ask this question. I think Anton's had a go at it in the chat, but I'm gonna put it out here for everyone to listen. Where we heard from a few paint suppliers that natural paints won't stick to existing acrylic paints because they can't cure into the substrate. How do you manage to get around that if you do have paint that can be used directly over existing plastic paints?
Yeah, that's a great question. We do have projects where it's not ideal, but the existing coatings are quite sound. Sometimes we get it on buildings when 3 out of the 4 elevations are perfectly sound, and there's one elevation that's got the failure. It needs to go back to the original substrate and needs a breathable paint coating. All of the other facades or elevations can still be decorated in time. We're using a variation of our potassium silicate, sol silicate, basically. It's a binding agent, a variation of that, which basically means our paint can act in 2 ways. It will chemically bond onto bare substrates, but at exactly the same time, it can form a film forming coating over sound existing paint. And I would stress, it has to be sound. If the underlying coat fails, it will just take our paint with it. You won't introduce any breathability because it doesn't work like that. It's more about introducing the visual aesthetic, the resistance to mold and fungal growth, the matte mineral finish, the natural look of it. Because sometimes it's not something people are always aware of. Trying to remove a sound existing paint coating can cause even more damage to the substrate than it's worth doing. Sometimes you are better off leaving it there. Another example is we have an elevation where 3/4 of the paint has failed, 1/4 of the paint is sound. It's better to leave that sound paint there, not cause the damage. Any trapped moisture will find its way to the sort of passage of least resistance, is my understanding. So it will just skirt around that sound paint and go through where there is breathability. I hope that answers the question.
Great, yeah, thanks. Right, there's a few left, but I'm very aware we're sort of we've been here a while. But if you guys are still happy to sort of carry on, take a few more. I'm just gonna quickly read one here for Paola. Oh yeah, Paola, this is interesting. Again from Michel of Bruns Linseed Paint. He quotes your report every time he does a presentation, but he gets challenged regularly on the figures. Quite a few people saying that tire waste is a bigger proportion of plastic waste. Do you have any info on this? And are all those figures you've shown sort of per year?
Yeah. So I think one reference that could be good is the one from the European Commission. So this last slide that I showed that compared different sources. And I guess, I mean, if you just want to take it from, this is the knowledge so far, and paint in that framework, paint looks like it could be the biggest, but if we took the lowest estimate, then the lowest estimate for both paint and tire, then tire would be more. But I think in general, like, where does the question want to go? Is it that do they want to go to the point that paint is not important because tire is more important? Because in the end, they just add on top of each other and they create more and more environmental problem and plastic pollution. So I think sometimes it is important to say, this is the biggest, if if you're concerned with attracting attention to a topic that wasn't really looked at before, and it can lead to more fundings and stuff like that. And I think a lot of people already know that tire is a source of microplastic pollution, tire abrasion, or I don't know, I guess in my field, people already knew, and paint was a bit of a novelty. And it could be that in the end, tire is more. But I do believe that microplastic pollution from paint is a problem, and that people are not aware of it. And the volumes, like you have these 90 million tons of plastic used in paint every year, and it's not easy to think of a well-managed fate for it.
Yeah, yeah. So Michelle's just replied there saying that he completely agrees. He just wants to make sure that he can answer with some authority. And I think that EU, I don't know, or paper that you referred to will give him that authority. So back onto lime wash quickly. Are there not hygienic elements in lime wash? Cow barns used to be whitewashed annually in their annual maintenance regime that someone's forgotten to stick on the notice board. So Tim, are there hygienic elements in lime wash?
I don't know.
And yes, there are.
I don't know. I'm not an expert in lime wash, nor am I an expert in mortars. I will tell you that until I started my PhD, I kept cows and I lime washed the cow house because it's very convenient to scrape the bulk of the shit off the walls and cover it with lime wash. But whether that constitutes it being hygienic or not is a completely different matter. But what is interesting is the way that lime wash has been used historically at street level and around doors and windows, and certainly within Glasgow and Edinburgh in the closes. Now, whether that's to help with light or whether it's to manage bacterial infection, I really couldn't say. But it's certainly an interesting question.
Yeah, no, I mean, I'm pretty certain that lime is sort of renowned for its antibacterial properties, and it's certainly used in all sorts of sort of farmy type scenarios. Said someone who's definitely not a farmer. Right. Back onto silicate paint. Curious to which countries minerals and silicates are generally sourced from. So that's a really important question. So where and whether the sourcing is traced and ethical and socially responsible. And the sort of second half to that question is the kind of the secret ingredient or that you mentioned in your slides, Anton. If we don't know what those secret ingredients are, how can we be kind of confident in the kind of is it a process or is it?
It's a process rather than an ingredient. How those materials are actually combined together. It's like the recipe of Mr. A.W. Kime. We're not going to tell everybody how he made his paint because then it's for everybody to make.
And then so the sourcing.
We have the highly acclaimed, very independent, very trusted cradle to cradle certification. So that process, totally independent, very thorough. They literally go from A through to Z. So the sourcing of our materials, how those materials are actually sourced, who, where, why, how they're transported to our main production unit in Germany, how the staff are treated, how the paint is actually made in the factories. How that's then transported all over the world to all of the different Kime subsidiaries, all the way through to end of life. So it is an extremely thorough process to get that certification. Like I say, it's totally independent. It's independently verified as well. And that's really our sort of answer to that question, to be honest. Historically, from A.W. Kime, our whole process and ethos has been about protecting and preserving historic buildings, being good to the planet, being good to people and good for people. The last thing we want to do is hurt or harm anybody at all, and we sort of stand by that, to be honest.
Fantastic. Okay, guys. I think that's enough questions for this evening. Although a couple do keep rolling in, but there's just one comment here that just come in that I think is worth reading. This is so Paola. We came across this is from Stanley Wilson. We came across your amazing report a few years ago, and together with some other triggers, we then completely removed plastic paint from our products, which is interior architectural lighting. They couldn't unsee what you'd researched, written. Just wanted to say thank you. And just that the very phrase used there, you can't unsee what you've seen is a staple of the Lime Finishes group that Tim has put a link to in the chat. So, I mean, I hope everything that you've heard here tonight there's an element of you can't unhear what you've heard this evening, and this will lead us to hopefully making better decisions for our buildings.
I just wanted to, like, sorry, before you conclude, to like, because I didn't thank people in the chat, but really it was a very pleasant experience, like a lot of supportive people and curious people. So I just wanted to thank everyone for the interest and the support.
Well
and
said.
for organizing.
Likewise, yeah. Thank you very much.
Thanks so much. And so I'll just hand back over to Steph then to finish up and end the webinar for this evening. So thanks very much from me, guys. That was amazing.
Great, thank you everyone. Thanks for coming, and yeah, as Tom said, brilliant presentations and really interesting Q&A, which always makes for a great event. Thank you. Just want to say thanks again to all our speakers for a brilliant evening, and thank you to everybody for coming, and we hope to see you again soon.